Okay, so f of x is equal to log of sin x, right? First we have to find f dash of x. So f dash of x is equal to log sin x derivative. First log x is 1 by x, that is 1 by sin x, then sin x derivative. Sin x derivative will be cos x. So finally f dash of x is equal to cot x. Cos x by sin x is cot x. Now the first subdivision. Okay, they did not given any subdivisions here. Case 1 means in interval. I'm taking the interval 0 to pi by 2. So in interval 0 to pi by 2, cot x is clearly greater than 0. I'm taking open interval, not closed interval, because cot 0 is infinite, so that I'm taking open interval. So whenever it is infinite, it is undefined. Undefined means it is not continuous. It is not continuous means how it will be differentiate? It is not differentiate. Okay, so open interval you should take. Continuous in closed interval generally. It is also not continuous at 0. So in open interval 0 to pi by 2, cot x is greater than 0. Cot x nothing but f dash of x. F dash of x is greater than 0. So whenever f dash of x is greater than 0, then what about that? Is it increasing or not? It is clearly strictly increasing. Nothing but always it is increasing. So f dash of x is greater than 0 for every x belongs to open interval 0 to pi by 2. Therefore, what shall we conclude? Therefore, f of x is increasing in 0 to pi by 2. Simple, students. F dash of x is greater than 0, increasing. That we know very well. Then second point. Second point is second case. Case 2 means second. So what I have done, simply I have taken the given function, I differentiated, we got f dash of x. So in given interval, I checked that f dash of x is greater than 0. So next one is in interval pi by 2 to pi. Pi by 2 to pi. Okay, second quadrant. In second quadrant, pi by 2 to pi, what about cot x, students? What about cot x? Is it greater than 0 or lesser than 0? Yes?
Lesser than 0.
Lesser than 0. Cot x nothing but f dash of x. So shall I write here f dash of x is lesser than 0 for every x belongs to pi by 2 to pi? Yes, we can write. So f dash of x is lesser than 0 for each x belongs to pi by 2 to pi second quadrant. So therefore f of x is decreasing. F dash of x is lesser than 0 means f of x is decreasing. Decreasing in the interval pi by 2 to pi. That's all. Hence f of x is decreasing, increasing 0 to pi by 2 and decreasing in pi by 2 to pi, like that. Okay. So 17th question number 17th is log of cos x. Here log of sin x in question number 16. Here log of modulus cos x. Okay. So you can do this question. So here 1 by cos x derivatives, modulus will be there. It's depending on, it cannot be take negative value. It will take only positive value. So that you can do this problem. 17th you can do. I'm going to do 18th one. Okay, here prove that, 18th question, prove that the function is given by, okay, cubic equation is given, is increasing entire the real line. Okay, in or we can show that, we can prove that given function is increasing. Nothing but what shall we do here? Simple, find f dash of x. it should be always greater than 0 for every x belongs to R. That's all. We have to prove that f dash of x is greater than 0 for every real number. So for that, what is the given function? Is it clear this question? F dash of x, I have checked that f dash of x value. 18th. If you want, you can note it down. So 18th question is, the given function is x cube minus 3x square plus 3x minus 100. Okay. So we have to prove that this is increasing in R. So find f dash of x. Differentiate, let us take equation 1, differentiate equation 1 with respect to x on both sides. So here we are going to get 3x square minus 6x plus 3. 100 derivative becomes 0. 100 is a constant. So f dash of x is equal to 3 is common. So x square minus 2x plus 1. Am I right? Then f dash of x is clearly equal to, what about here? X square minus 2x plus 1 can be written as
x minus 1 whole square.
x minus 1 the whole square. Okay, now I want to check f dash of x whether it is greater than 0 or greater than or equal to 0 or lesser than or equal to 0. For that, what shall we do here? Clearly, here 3 is the greater than 0. We cannot write directly. You may write like this, comma x minus 1 whole square also always greater than or equal to 0. It is strictly greater than 0. It is greater than or equal to 0. So which implies 3 into x minus 1 whole square is greater than or equal to 0. Okay, nothing but this is nothing but f dash of x. F dash of x is greater than or equal to 0 for every, give any x value here. Substitute, take any x value for every x belongs to R. It is always greater than or equal to 0. Whenever the derivative of f of x is greater than or equal to 0, therefore, what about fm? Therefore, f of x is always increasing in capital R. Clear, students? What I have done? I found f dash of x becomes 3 into x minus 1 the whole square. So 3 is greater than 0, x minus 1 whole square is greater than or equal to 0. Finally, f dash of x becomes greater than or equal to 0 for every x belongs to R. Therefore, it is increasing in R. That's all. Okay, next. If you have any doubts, you can ask. So all of you check this. X square into e power minus x is increasing in which interval? So for that, what shall we do here? Find f dash of x equating to 0. Find critical values. So what is the function? Y is equal to x square e power minus x. I think so. Question number 18 is very clear, right? Question number 19, last question. They given y is equal to x square into e to the power of minus x. Okay, then what shall we do here? Differentiate again. dy by dx is equal to uv rule. Okay, so what is u and what is v here? U is x square, v is e power minus x. Since we know that d of uv is equal to uv dash plus u dash v, right? So with help of this, x square into e power minus x derivative is minus e power minus x plus e power minus x into x square derivative is 2x. Simple. Okay. So I applied UV rule now minus. So what is the common here? We may take e power minus x is common. E power minus x is common. Then okay, minus x square plus 2x. Shall I? Okay, you may take also e power minus x, and even you can take minus x also common. Yes, sir. No, minus x common means here x minus 2. So this dy by dx, you may write f dash of x also. If I take your f of x is equal to y, f dash of x value is dy by dx. So finally f dash of x value we getting like this. Okay. So now for increasing or decreasing, we have to equating to 0. F dash of x equating to 0. F dash of equating to 0 means e to the power of minus x into x minus 2 is equal to 0. Clear? So I applied UV rule, have taken whatever it is common, e power minus x into minus x is common, remaining. So after this, see students, here e to the power of minus x should not never becomes 0. That we know that. Minus x, okay, equating to 0, it is possible. X minus 2 also becomes 0. So when this value LHS becomes 0, e to the power of minus x not equal to 0 for any value of x, but minus x becomes 0, x minus 2 is become 0. So that what are the x values, which implies x is equal to is 0 and 2. So now the given real line, we can divide it into disjoint subintervals. Okay, so what are the values we got it here? 1 is 0, 1 is 2. So they did not given any interval in the question, so that you should take from minus infinity to plus infinity. Any interval is given here? No. Right. Now we have to check f dash of x whether it is lesser than 0, greater than 0 in given intervals. Before that, tell me what is f dash of x here? F dash of x is e power minus x x minus 2. Okay, students, now 2 to infinite. 2 to infinite, whatever the function, is it lesser than 0 or greater than 0? Take any value. So e to the power of minus x always greater than 0. E to the power of minus x always greater than 0. Then what about from 2 to infinite this f dash of x? Clearly I have written here. 2 to infinity you may take 10, 3 to infinity. Any value you can give here. Yes. Increasing or decreasing? Increasing. Is that increasing? Decreasing. Because we will get negative value. Okay, for any value of x it is negative. So like negative will get, so that decreasing. Here then we'll get positive, I think so. Increasing, negative. So in which interval? So plus means increasing, minus means decreasing. So what is the correct answer, students? Option? See here. From 0 to 2, it will always positive. Take any value, like 1 you can take, 1 you can give, will get positive. So 0 comma 2. So option D. Okay, I go through the procedure because I calculated the f dash of x, I equated to 0, we got x values. Divide the real line minus infinity to infinity as subintervals. Like minus infinity to 0, it is decreasing. 0 to 2, it is increasing. And 2 to infinity, substituting some x values. You can check it. So easy. Is that clear, students? Any doubts here in max increasing, decreasing? Yes.
Now can you show the 16th sum, sir?
16th sum. The next topic is maximum, minimum.
Okay, sir. Thank you, sir.
So next topic, maximum minima, that is very important topic, because we may expect one 5 marks question or else one case study question. Okay, most important topic, maximum minima in calculus. Okay. So maximum and minimum. Right. Right now in this class, I'm going to explain you the concept. All of you observe very carefully. Okay. And very important topic, right? Okay, right. For example, they given a function. Function means f of x is equal to x square. F of x is equal to x square. Then what about this x square, students? Okay, what about this x square? The graphical representation of x square is, we are going to get like this. Okay, so we are going to get like the graph becomes, it is open upwards. Yes. So this is a parabola. F of x nothing but y is equal to x square means x square is equal to y. So it is in the form of x square is equal to 4ay. Okay, x square is equal to 4ay is a parabola. It is always open upwards because x square coefficient is positive here. Here x square coefficient is positive. So whenever it is positive, it open upwards. So whenever it is open upwards, it will see, if we extend the graph, it will tends to where? It will tends to till infinity. Infinity is neither maximum nor minimum, because maximum here in this maximum minimum, we are finding a finite value. Since we know that it will be tends to infinity, the maximum value is infinity. But whereas in this function, so is this function will give a minimum value or maximum value? Yes?
Maximum.
No. We can find minimum
Minimum.
value. Maximum we can say directly infinity. It will tends to infinite. When x is increase, y also increase. See here, x is 1, y also 1, x is 2, y is 4, x is 3, y is 20, 9, like that. When x is tends to infinity, y is tends to infinity. Nothing but here the value in the sense y value. We can consider the maximum minimum is given by y value. At what point it is maximum is the point will given by x values. Okay. So once again, so if I take f of x is equal to plus x square, the graph of the function is u-shaped. It is a parabola. It will be open upwards. So when x is increasing till infinity, y is also tends to infinity. So here maximum is infinity. We don't know maximum. Maximum is clearly infinity. So in this case, we will get minimum value. Minimum value. So in this x square, what is the minimum value, Amma? Minimum value is clearly y is equal to 0. When x is equal to 0, y value is 0. This is the only minimum. If I take x minus 1 the whole square, or x square plus 3x plus 4 something, this is also a quadratic equation. Every quadratic equation is a parabola. Every quadratic equation represents parabola. Okay, this is also u-shaped. But in this case, so depending on the equation, we'll get different values, minimum value. First, tell me, what about this quadratic equation, whether it will give minima or maxima? That's you want to know. Okay, so here it is clearly quadratic equation in the form of ax square plus bx, ax square plus bx plus c. So what is the x square coefficient is? A. X square coefficient is A. When A is greater than 0, we get always the function will give a minimum value. Remember that. Okay. When the coefficient of x square A is lesser than 0, it will give a maximum value. Because take here, I'm going to take a f of x value is f of x is equal to minus x square. So what is the graphical representation of minus x square? It will be open downwards. This is the graph. Clear, students? So whenever it is open downwards, when x is increasing, what about the y value, students? Yes, x is increasing, y is minus x square, decreasing. Decreasing in this case, so we are going to get a minimum value or maximum value?
Maximum.
Maximum, because when x is increased, y tends to minus infinity. Here, y tends to minus infinity, so that we are going to get a maximum value. So whenever it is a quadratic equation, so what about maximum and minimum? Maximum and minimum values is given by maximum and minimum. Value is given by only one formula is there, that is minus d square by 4a. So what is capital D? Capital D is a discriminant. Okay. So if the given function is a quadratic equation ax square plus bx plus c, the maximum or minimum value is given by only one formula, that is minus d square by 4a. So where capital D is equal to b square minus 4ac. Okay, you may get doubts, sir. Same formula in. So how can we say whether we'll get it will give minimum or maximum? Simple. So it's depending on if I give the function like this, x square minus 2, then in this case we'll get maximum value or minimum value? Yes.
Minimum.
Yeah, minimum, because just observe the x square coefficient, whether it is positive or negative. Yes, here it is clearly positive, so that we'll get minimum value. Yeah.
Can you explain like the maxima and minima concept again?
Yeah, see, maxima and minima concept, to find maximum value or a minimum value of the given function, there are 2 or 3 methods are there. In that, at first I'm giving some example to check whether I'm not finding exact minimum value, exact maximum value here. So by seeing the function itself, how can we identify whether the given function has maximum or minimum? Okay, maximum value or minimum value. Okay, so first case, I'm taking the quadratic equation. So when the quadratic equation having maximum, when the quadratic quadratic expression having a minimum value. So whenever x square coefficient here, x square coefficient is positive, it will give a minimum value. So how to find that minimum value at the particular point, I will explain you later. Okay, x square coefficient is positive, the given function will give a minimum value. X square coefficient is negative, so the function will having maximum value. That you have to remember. I will tell you mathematically how to find maximum minimum values. Okay, so for example, I'm going to take the curve like see here. I'm going to take the graph of the function like, okay, the curve I'm going to take like this. It is a very interesting and okay, right. I'm taking the function, the given interval, I'm taking this is A, this is B. I want to check maximum minima in the open interval A comma B. See students, when you observe here, the curve having few maximum values, few minimum values. Like, okay, see here, is this maximum value or minimum value? Yes,
Maximum.
maximum. What about this?
Minimum.
Maximum, minimum, maximum, minimum, maximum. See here, so at what point it has maximum? See, I'm going to take some point here, like, okay, this point I'm going to take as at C1, C1. This is at C2. This is at C3. Here, this is at C4, C4, at C5, and this is C6, C7. Okay, so we can split the given interval into, we can divide the given interval AB into some sub interval, A to C1, C1 to C2, C2, C3, C4, like that. So we don't want here. So what about the C1, C2, C3, C4, C5? So it will be represent point of maxima, point of minima. Okay, when you see that at C1, we get the value is f of C1. At C2, we'll get f of C2. Okay, f of C2 means Y1. Let us take Y1. This is Y2, like that. This is f of C3. This is f of C4. This is f of C5. This f of C6. F of C7. This, okay, that's all. Right, see here at C1, C1 is a point. At this point, what about the function? Function will give a maximum value. What is that maximum value? F of C1. At a C2, at the point C2, the function having minimum value. What is that minimum value? F of C2. They give a function. Surely they give a function y is equal to like y is equal to f of x. So at that point C1, I want to know whether the given function having maximum or minimum. So with the help of this graphical representation, if you observe that the function having a minimum at a C2, it has at C1 it has having maximum, at C2 it is minimum. The minimum value means this C2 you can substitute in given function. In place of x, substitute C2 here, f of C2 will give a minimum. Now substitute C3 in given function, it will give maximum. And it is C4. F of C4 minimum, F of C5 maximum, F of C6 minimum, F of C7. Okay, in that among all this, here, here more than one minimum value we are having, more than one maximum value we are having. So here f of C1, f of C3, f of C5, f of C7 will give a maximum values. So this all maximum values are called local maxima. Remember students name, local maxima. Okay, these are all local maximas. So in that, what about among all these f of C1, C3, C5, C7, what is the value will be highest? Yes,
C5.
f of C5 will give highest value. Am I right? This f of C5 is called absolute maxima. There are more than one minimum values are there, but there is only one absolute maxima will be there. Absolute maxima. So whatever the among all the maximum, whatever the maximum value we having, that is called absolute maxima. Remaining all called local maximas. Local maxima. In the same way, if you see that f of C2, f of C4, f of C6. So these are called local minima. Okay. And what is absolute minima here among all three? Absolute minima,
C6.
f of C6. This is called absolute minima. Okay, then fine. Okay, there are two types of maxima, two types of minima is there. Local minima, absolute minima. Local maxima, absolute maxima. Is it clear, students? Local minima, local maxima, and absolute
If
minima,
all
absolute
minimas
maxima.
are the same line, sir.
Yes, all
Sir, if all the minimas are the same line, sir.
all minimas.
Sir, if all the minimas are on the same line, sir, the same height.
No, 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 not like that. So whenever it is having same height, we cannot take a different like f of c2, f of c4. We'll write only one value. Simply we can write, for example, f of c2, f of c4 having on the same line. Just you can write only one value, either f of c2 or f of c4. That's all. Okay,
Okay,
this
sir.
side, right? And also here, next question is how to identify whether the given function having a local minima, local maxima. Because in the question they don't mention that find, sometimes they don't mention that find minima, absolute minima or absolute maxima, local minima, local maxima. Then how to identify those questions? Very simple, student. Whenever they want to they want to ask that find absolute maxima, absolute minima. Okay, whenever we want to find absolute maxima, absolute minima, in the question they'll give the interval. Surely they'll give the interval like increasing, decreasing, increasing, decreasing. Prove that question, they give interval. So remaining question they do not given the interval. In that we have taken real line. Here also whenever we want to find absolute maxima, absolute minima, they'll give the interval. If they do not given the interval, just we can find local maxima, local minima. That's all. Okay, fine. So these are called local minima, local maxima. Then what is the procedure to find, what is the working rule to find the maxima and minima of the given function? Okay, there are two methods. First derivative test is there, second derivative test is there. Okay, let us see the working rule which is applicable for all the question. Working rule. Okay, so what is the working rule? Now I'm going to explain. Right, first f of x be the given function in the interval. It may be open interval, it may be closed interval. Okay, f of x is defined in the interval a comma b. So now I want to check the given function having a maximum value or minimum value in given interval. So you can take like any for example, f of x is equal to x square from -2 to 2. Now in this interval we get the graph like this. So up to here only -2 to +2 alone you can take the interval. No need to take a remaining value, remaining -3, +3. No need to take any other values. From -2 to 2, whether the given function having maximum or minimum. In this case, it is clearly given function is a quadratic. We can say very easily because x square coefficient positive, it is always having minimum value. Okay, minimum value. But other than x square, if they give x power 1 by 2 and x power 5, x power 6, sin x, tan x, hyperbolic function, logarithmic function, that time we can't say whether it is having minimum or maximum. So in such type of all types of functions, so only one method. First, take the given function. First step is we have to differentiate, like increasing, decreasing. We have to differentiate and equating to 0. Equating to 0. So we are going to get some x values like a comma b comma c, something you can take. It may be one value, it may be like increasing, decreasing only up to here. In increasing, decreasing, every function we differentiated, we equating to 0. We got critical values. Here also we get a critical point. Same here also will get critical points. After getting the critical points, what to do? In case if they give interval like this, very simple students, here interval I'm taking a comma b, so that these x values you have to take as C1, C2, C3, C1, C2, C3, like that. In graph also I have used that C1, C2. Interval is AB. I'm taking the critical points are C1, C2, like that. Okay. So what shall we do in this case? Simple, students. These critical values as well as the given end of the interval. End of the interval a comma b is there. All values you can substitute in given function. You find f of a value, you can find f of b value, and you can find f of c1 value, f of c2 value, so on. So among all these values, whatever the value, so whatever the value is the highest value, that will be the maximum. Whatever the value is the least value, that will be the minimum. That minimum value, maximum value is called absolute maximum, absolute minimum. Okay, simple first method. This is with help of first derivative test when they given the interval. When they given interval, you can do. When they do not given any interval, we can go for second derivative test. Second derivative test. That I'll give some example also.
Sir,
Yes, break.
sir, what is the condition, sir? F of a equal to comma you wrote.
F of a, substitute simply this a value, substitute in given function. B value you can substitute given function. For example, I want to know this f of minus 2 will be there. I want to find maximum minimum of the given function x square in the interval minus 2 to 2. So what shall we do here? Differentiate first. What is f dash of x? 2x. This 2x is equating to 0. What is x value we got? 0. Is 0 is belongs to given interval or not?
Yes.
Yeah, 0 is clearly belongs to. So finally, how many values are there? X values. X values. End of the interval first. End of the interval, one is minus 2. Another one is plus 2. And critical point we got it 0. And x is equal to 0. Here we don't want to like divide as a subinterval, not required here. So they given a particular interval minus 2 to 2, and end of the points are minus 2 plus 2, and we got one critical point x 0. All three values you can substitute in given function. F of x is equal to x square. F of x is equal to x square. Now what is f of 2? F of minus 2 value? Minus 2 square, 4. What is f of 2? Same, 4. What is f of 0? 0. Now among these three values, what is the highest value? Yes?
4.
Yeah, 4 is the maximum value. This is called absolute maximum. What is the minimum value among these three?
0.
Yeah, 0 is minimum value. This is called absolute minima. So this is the highest maximum value of the given function f of x is equal to x square at minus 2 comma 2 in that interval. So here this minus 2 is plus 2 is called point of maxima. At that point only, no, the function having maximum value at minus 2 plus 2. This point is called point of maxima. The value is 4. Here 0. So this 0 is called absolute minima, and this point 0, point x is equal to 0 is called point of minima is 0. The minimum value is 0. Here point of maxima is minus 2 and 2. The maximum value is 4. Value is 4. Point of maxima, point of minima is given by x values. And the value, maximum value, minimum value is given by f of x or else y. This f of 2, this is called y also. Y. Okay, students, after break, again I can explain you the concept very briefly. Try to